Hello judges, welcome to our science fair project, which takes a novel approach to classify human activity using neural net algorithms. Currently in the United States and across the world, millions of senior citizens face motor impairments with no convenient solutions that can provide accurate data about actions they are performing. Our project set out to create a neural net that could successfully classify human activity with a high level of accuracy.
The basic principle behind a neural network is its ability to decode meaning behind numbers. Its classification ability stems from an externally labeled dataset. The neural network scans the dataset for patterns in falling and walking, and it compares them to patterns in live gyroscope values. When the neural network finds a pattern similar to a verified pattern, it recognizes and classifies it. Not only can the neural network distinguish involuntary motion, it can also identify someone's walking pattern and make better predictions based upon different patterns.
For this experiment, we chose two simple tasks, walking or falling. We trained the neural net using two datasets. One was gyroscopic values while the individual was walking, and the other was gyroscopic values while the individual was falling. Our goal was for the neural net to score higher than a 75% accuracy for each classification. We simulated a human using a simple gimbal and performed a walking pattern for 50 trials and a falling pattern for the other 50 trials.
Demonstrated here is one of us performing these trials. The neural net printed a 1 or a 0 depending on whether it thought the individual was walking or falling. We performed the trial for 10 seconds. As you can see on the screen, while the individual was falling, the neural net on average printed a 1 and therefore successfully classified the action of the individual. We found our neural net to have an accuracy of 88% while walking and 90% while falling, which was far above our expectations of 75%.
To prove the application of this technology, we then extended this idea to active assistance through the idea of a reaction wheel belt. If the neural net made the determination that the individual was falling, the neural net would activate a self-stabilization algorithm that used brushless motors to counteract the falling motion.
The applications of this technology are limitless. First, it is possible to classify far more activities than just walking and falling by simply creating more datasets of different actions. This can extend to running, idling, jogging, and many more. The accuracy of this classification would also be relatively high because the neural nets will learn the patterns specific to that individual.
Second, it is possible for the neural net to be contained in a much smaller form, like a cell phone, which would use the gyroscope within the phone to create classifications on the human activity. The form factor would require no additional hardware the senior would have to carry around and provide a very convenient solution.
Finally, it is possible that the neural net code could automatically alert emergency services in the event that it detects that a person has fallen. Current solutions require that an individual press a button or manually call 911. However, now, using the neural net, it can automatically call on behalf of the individual with no additional input required.